us try this example. The questions asks us to use Laplace transform to solve these differential equations, given that when x is equal to 0, y equals to 3, and dy dx equals to 7. To solve these questions, first copy down the functions. Laplace transform the entire expressions, which including performing Laplace transform for every single term within the expressions, including the constant number. What you see, there will be second level derivatives and first level derivatives. Expand those by using the equations of the first and second derivatives. Substitute this into the functions and substitute this into the functions. You will obtain this. Based on the informations, when x is equal to 0, y equals to 3, that means y0 will be equals to 3. And when x is equal to 0, dy dx equal to 7, that means y prime 0 will be equals to 7. Substitute this value into the functions here. You will get this. Now rewrite the functions so that Laplace y is on one side while the rest on the other side. Take out the Laplace y from the function. You will get this, and this is to be brought to the opposite side of the expressions. You will get this. In order to determine the y, you need to inverse Laplace transform. To do so, you will have to rewrite the functions here in reference to the formula list for the Laplace transform. Try to arrange the functions so that it fits structures of the functions. That can be done with the inverted Laplace transform. For the function here, it can be rewritten in the manner of this, where 9 plus 4 will be equals to 13. This can be factorized into s plus 3 squared, and 4 can be presented in the mode of 2 squared. This can also be rewritten in this form. And these functions can be separated into two terms, which can be done on the Laplace transform for two terms. From here, you may move up the constant 3 out of the functions. Same go to here, 16, you can move out the constant 8. What is remaining will be 2 within the function here. Now you have rearranged the functions in accordance to the structures of the inverse Laplace transform. Refers to the formula in the tables of formula. Based on the structure here, you are able to identify the alpha and omega in the functions, and the outcome of the inverse Laplace transform are given here. This can be further simplified into this.